Hello and thank you for watching this video on intercepts and zeros. In this video you will learn to determine the intercepts using a graph, and then you will find the zeros and the y-intercepts algebraically. We'll begin by going over what the x and y-intercepts are. Your x-intercept is simply going to be the coordinate where the graph crosses the x-axis. This occurs again when y is equal to 0. So these points here, as you see on the graph, let me write them in red, have the coordinates format of x and then 0 for the y. Similarly, the y-intercept are going to be the coordinates on the graph that crosses the y-axis. This occurs when x is equal to 0. So that means that the format for this coordinate will be where x is going to be the value of 0, and the y is going to be whatever this y coordinate value is. So they have this format for the y-intercept. So let's look at some examples. In this example right here, this graph has both an x and a y-intercept. The y-intercept is located here in red, which has the coordinate of 0 to 2. Let me write over here instead. And the x-intercept, which I'll write in blue, is located here, which has the coordinate point of 4, 0. So those are your x and y intercepts. Now, not every graph has both an x and y intercept, or has only one x intercept. Like in the example right here, this graph has 1, 2, 3, 4 x intercepts. So our x intercepts are at -1, 0, at +1, 0, at 2, 0, and at 3, 0. So our 4 x intercepts. It does, however, only have one y-intercept. And because these things are going to be functions, we're going to be focusing mostly on functions. The functions can only have up to one y-intercept. It can only cross the y-axis no more than once. Like right here, they were crossing the y-axis at 0, 6. So that is our y-intercept. It could be that our graph doesn't cross the x-axis, like in this example right here, but it does cross the y-axis at that point there. So our y-intercept is at 0, 5, and we have no x-intercept because we do not, as you see, cross the x-axis. Another situation that could arise is that the graph doesn't cross either axis, neither the x or the y-axis, like in this example right here. In this situation here, the graph does not cross the y-axis nor the x-axis. These situations here occur when the graphs have isentops, and that's exactly what's happening here. This is the function 1 over x, named the reciprocal function, and this occurs a lot with these type of situations. We have x in our denominator, where we have possibly a vertical isentope and some type of horizontal or maybe even a diagonal isentope where the graph is not going to cross. For this particular function, the graph does not cross neither the x nor the y-axis, so there are no intercepts. And again, this is something that could possibly occur. Now, in the second half of this video, we're going to go over, okay, how do I find these intercepts algebraically? Well, let's start with a different terminology, first of all, for the x-intercept. The x-intercept is sometimes referred to as the zeros when we're doing this algebraically. And it's not only for quadratic functions. I know on this slide here, it says that the x-intercept, the zeros are the x-intercept of a quadratic function. That's not true. It's not only for the quadratic function. It's for any function. This should be more clear. It should be any function where y is equal to 0. So we're just simply, as you see right here, our x-intercepts are just simply referred to as 0 sometimes. And we're going to identify these zeros algebraically. The way that we do that to find the zeros algebraically is that we set the y value, which is the same thing as f of x, equal to 0, and then we solve the equation for x. To find the y-intercept, we are simply going to evaluate the function when the x value is equal to 0. So on 1, to find the zeros, we have y equal to 0, and to find the y-intercept, we have x equal to 0. So let's look at some examples. In example number 5, here we have a linear equation. We'll start by first figuring out the y-intercept. To do that, all we're simply going to do, let me use this equation y and not write it in function notation. Let me write y is equal to 5x minus 9. So to figure out the y-intercept, all I do is replace the x with 0 and solve the equation for y. So we end up that y is going to equal to negative 9. So this is our y-intercept. Our y-intercept is negative 9. Well, 0, negative 9, but for right now, we're just going to list them from this point on. So we're crossing the y-axis at negative 9. Now, if we want to find the x-intercept, we just simply do the opposite. Instead of having y equal to 0, we have, x equal to 0, we have y equal to 0. So we get to this value of y and replace it with 0. So that means that 5x minus 9 is going to equal to 0. And all we do now in this example is solve this linear equation. We add 9 to both sides. We divide by 5. And this solution for x, this value of x equaling to 5 over 9, that is my x-intercept. So this is my x-intercept, which again we are now calling the 0. So we have the 0 of 9 over 5. So what this means is that if I plug this number into the value of x, that's going to make the equation equal to 0. And again, you can check and verify that this is true. 5 over 9 x minus 9, 5x minus 9. Replacing the x with 9 over 5 gives me 9 minus 9, which again is equal to 0. That's why it's referred to as 0. That's why this value here is referred to 0, because it makes the function, the equation, equal to 0. Let's look at a different example. So here, for the rest of examples, we're going to doing the exact same thing, finding the 0 and the y-intercept, but we're going to look at different functions just to review again how we would solve these functions. We'll start with the y-intercept, since it'll be the same. And all we have to do is just simply follow our order of operations. We're going to replace the x with 0. And for this example, we work inside the absolute value symbol first. So that's going to give us negative 5. Now the absolute value makes everything positive. So this negative 5 is going to become a positive 5. I've replaced the absolute value symbol with parentheses. And the only reason I did that is because of this negative 1 that we have on the outside. Okay. So this negative 1 is being multiplied with the square root of, with the absolute value of negative 5, which becomes positive 5. So multiplying a positive 5 with a negative 1 and then adding 3, we're going to get that the value of y is positive 2. So that's my y-intercept. We're going to cross the y-axis at positive 2. Now to find the 0, aka x-intercept, we're now going to make the y equal to 0. So we have negative 1 times the absolute value of x minus 5 plus 3 equal to 0. So what we're looking for is the value of x that will make the function equal to 0. So here, because we have an absolute value equation, the way that we solve this, if you recall from Algebra 2, is that we create two cases. We create the case again where this inside here is going to be to the right of 0, which makes it positive. Well, in other words, keeps again the value the same. That's the first case. And the second case is if it's the inside the absolute value is to the left of 0. So that's negative 1 times negative x plus 5 plus 3 equal to 0. And just to recap again real quickly why we create these two cases, because consider again this example here. Let's say that the absolute value of x is equal to 7. There's two possibilities. There's either positive 7 or there is negative 7. Because remember, the absolute value gives you the distance from 0. So here, we have to consider again the two cases where we can take the positive absolute value of 7, and that's going to give us 7, or we can take the negative absolute value of 7, which also equals to 7. So considering those two cases, we use again the first case keeps everything the same, and the second case again considers it if it's on the left side, on the negative side, which means that everything becomes the opposite. So solving these two cases individually, we're going to get two different intercepts, meaning we're going to cross the x-axis in two different locations, two zeros. So let's see, here we would distribute the negative 1 first, so negative x plus 5 plus 3 is equal to 0. Subtracting the 3 and the 1 from both sides, we get negative 5 minus 3. We end up with negative 8. And then dividing by negative 1, we get that x is equal to 8. So this is one of the zeros. To figure out the other zero, again, starting by distributing, we get a positive x this time, a negative 5 plus 3 is equal to 0. Adding the 5 and subtracting the 3, we're going to get that x is equal to 5 minus 3, which simplifies to 2. So here are the two zeros, which again graphically simply mean that we're crossing the x-axis at positive 2 and at positive 8. Algebraically, this means that if I plug in the number 2 in for the value of x, this entire thing will equal to 0. And if I plug in the number 8 into the value of x, again, this entire thing will simplify to 0. Everything will cancel out and we just end up with 0. Now the next example I want to review, and again, is a quadratic, a trinomial. Well, to find the y-intercept of this simply means to replace the x's with 0. So y will end up with 0 squared minus 7 times 0 minus 18, which is simply going to equal to negative 18. So that is our y-intercept. Now to find the 0 of this function, we're going to replace our y value with 0, and we end up with the equation of x squared minus 7x minus 18 equal to 0. So we want to solve this equation. To solve this equation, well, we're going to use factorization. Any trinomial written in this format should be able to be written as the product of two binomials. So what two things can I multiply to equal, that gives me this, that's equivalent to the trinomial. So using factorization, we know that x times x equals x squared. These two multiply to equal to that. But here comes the hard part. Okay, what factors of negative 18 can I use? And there's several possibilities. I can use negative 18 with a positive 1, or backwards, a positive negative 1 and a positive 18. Or like I said, the opposite, a positive 1 and a negative 18. I can use 2 and 3, a negative 2 and a positive 9, 9. Or the opposite, a positive 2 and a negative 9. Those two things multiply to give me negative 18. Or 3 and 6, a negative 3 and a positive 6 multiplies to negative 18. Or the opposite, a positive 3 and a negative 6. Those two multiply also to a negative 18. Of those various combinations, the one I'm going to do or use is the one that adds up to this middle number right there. So I want the two numbers to multiply to give me a negative 18, but then I want them to add or combine to a negative 7. And the only combination that does that is when I use a negative 9 and a positive 2. Negative 9 times a positive 2 is equal to negative 18, but then a negative 9 plus a positive 2 is equal to -7. See how I end up getting again those two numbers there? So this is the combination I'm going to use again multiplying that set. So this is my factor. Now that I have the factor, I'm going to use a very important property in math that states if the product of two things is equal to 0, then there's only one possibility. Either A is equal to 0 or B is equal to 0. One of the two factors has to equal to 0. And I'm using again this inclusive OR, meaning that it could possibly only be one of them, or it could possibly be that both of them are 0. So we're using that type of OR. So we're going to do exactly that. We're going to get that either the first parentheses is going to equal to 0, that's one of the products, or the second product has to be 0. And then solving the two cases, the two equations, again my first case and my second case, I get that x is equal to +9 or x is equal to -2. And like I said, since I'm not clear on which one is could it possibly be, I include both of them. So those are the two zeros. Those are the two things that are going to make this thing equal to 0, meaning that I'm going to cross the x-axis at +9 and cross the x-axis at -2. So those are my two zeros. Here are this is my y-intercept. And this is how you solve for this type of equation, or the type of find the zeros for this type of function using factorization. And the last example we're going to go over is a radical equation, a radical function. To find the y-intercept for a radical function like this one, again, we simply replace the x variable with 0. And following order operations, we would add 0 and the 1 before we take the square root. And since the square root of 1 is 1, we end up subtracting 1 minus 2, which is -1. So our y-intercept is -1. So we're going to cross the y-axis at -1. Now to find the x-intercept, aka our 0, we're going to simply replace the y value with 0. So that means the square root of x plus 1 minus the 2 is going to be set equal to 0. And then solving for this, we would start by adding 2 to both sides, so we can isolate the square root. And that way we can then solve this by raising this to the second power. That will get rid of the square root, and we're left with x plus 1 is equal to 4. Subtracting 1 from both sides, x then equals to 3. So this is the 0 to this function, and we only cross the x-axis at one location, at 3. Okay, so that concludes again this video here on finding the zeros and the y-intercept algebraically, and how to find those exact same things simply by picking them up from graphs. Again, which are known as your x-intercept and y-intercept. Okay, well, thank you again for watching. If you do have any questions, again, email me, and I hope you have a wonderful day.